All right, let's get started with functions, and we are going to start by identifying domain, range, and end behavior. First of all, an interval is a part of a number line without any breaks, meaning it continues on, and we can create any type of interval we want. We can go by ones, we can go by halves, we can go by tens. Any interval as long as we have a number line without any breaks. A finite interval has two endpoints, which may or may not be included in the interval. Now, the word finite should give it away, right? Finite, finish, it finishes. It starts and it finishes. An infinite interval is unbounded on one or both ends, meaning it can extend from negative infinity to positive infinity, or from 0 to infinity, or from negative infinity to 0. So as long as you have one endpoint or no endpoints, it is an infinite interval. All right, so let's go ahead and look at different notations and see how we can use them to represent intervals on a number line. We will fill in the table with the information. So the first description we have is all real numbers from A to B, including A and B. So this means we are looking at a number line that starts at A and ends at B, and they are included. Because we have two endpoints, this would be a finite interval. Okay. Now, as an inequality, think back to when we learned inequalities, right, in middle school. We learned about inequality symbols, and we learned less than, greater than, less than or equal to, and greater than or equal to. Now, when we look at the number line from A to B, our inequality can be written as A is less than or equal to X, less than or equal to B. Set notation. Set notation uses curly brackets, and I know they're not that easy to draw, but you'll get better at them as we go. So how we define this is we draw a curly bracket and we define what we are talking about. Okay, in this case, we would say the domain of X, and then we draw a straight line. That line represents such that. So the way we read this, the domain of X such that, and then we list our inequality, right? Our limits. So in this case, we just rewrite our inequality from A to B and close our curly brackets. Okay, that is set notation. Now, interval notation. And this is something that you may have never seen before. So interval notation uses a combination of brackets, parentheses, or a bracket and a parentheses. Okay, what you need to know about these symbols, anytime we have brackets, it means that our points are included. Okay, so just like with inequalities, anytime we have greater than or equal to or less than or equal to, right, that equal sign indicates that it is an included point. Brackets work the same way. We include those points. Anytime we have parentheses, it means that our point is not included. Okay, and when we have a combination of a bracket and a parentheses, it just means that one end is bounded, whether it is included or not included, and then it can continue on or terminate being an included or not included point. So you can have a combination of both. Okay, now for this example, because we are looking at all real numbers from A to B, including A and B, we're going to write it as a point, A comma B, and draw brackets around it. Okay, brackets include the point. Now, our second example says all real numbers greater than A. Well, again, if we look at our number line, for this one, we're looking at everything past A, right? Even passing B. So in this case, this would be an infinite interval. Oops. Infinite interval, okay? How do we write it as an inequality? Well, we're looking at all values greater than A. Remember, this time we are not including A. It's telling us we are simply looking at greater than A. Set notation, once again, curly brackets, define our domain for x such that all real numbers greater than a. Okay? Now, interval notation. How would we look at interval notation? Well, in this case, we know that we're going to start at a, right? A is our beginning, and it's always read from left to right on our number line. So we're starting at a, and because we have no endpoint, we are extending it past any number to infinity. We don't have an endpoint, okay? Now, we know this is not equal to, we are not including a, so we use a parentheses. And anytime you are using infinity, you always use a parentheses because infinity cannot be included. Okay, so make a note of that. Infinity always has a parentheses. And our last example says all real numbers less than or equal to a. So in this case, we're starting at a, but we're looking at everything to the left of a. Again, it is infinite because we don't have an end in sight, right? And write our inequality just as it's written. It tells you less than or equal to a. So all values less than or equal to a. Define our domain, defined as x such that x is less than or equal to a. Okay, now just like the example above, I mentioned we always start from the left. So if we look at our number line over here, well, I don't know where we're starting, right? It's never terminating. It just says we're looking at everything less than a. That means we are coming in from negative infinity up to a. So interval notation starts at negative infinity and terminates at a. Infinity, always a parentheses. And in this case, remember we were told that all values less than or equal to a, so we are including a. We use a bracket around a. Okay? Now, again, make sure you are reading your number lines always from left to right. So let's go ahead and do a few examples here. Looking at a, we are looking at this first number line. We are going to write it as an inequality, as set notation, and then interval notation. Okay, and again, always from left to right. Okay, now in this case, you can see that we have a closed circle at 3, and we have, or negative 3, and we have a closed circle at 2. So we know that we're including those points, right? So I'm going to start from the left, negative 3 to 2, as an inequality less than or equal to x, less than or equal to 2. It's that simple. Set notation, curly brackets, define our domain such that negative 3 is less than or equal to x, less than or equal to 2. And interval notation, from left to right, negative 3 to 2, both points are included, so we use brackets around these 2 points. Our next example, we have an open circle this time at negative 3 and a closed circle at positive 2. So we're going to go negative 3 to 2, right? Now in this case, remember, because it is an open circle, that tells us that 3 is not included. It is just less than x. And because we have a closed circle at 2, that tells us it is included. So we go less than or equal to 2. Okay? Set notation, curly brackets, define for x such that negative 3 is less than x, less than or equal to 2. Okay? Interval notation, we go from negative 3 to 2. Those are our bounding points. We do not include negative 3. It is an open circle, but we do include 2 because it is a closed circle. So in this case, we do have a combination of parentheses and brackets. All right, so we did 2 of those together. Go ahead and hit the pause button and do letter B. Go ahead and do both of those. All right, so this is what you should have for B. The first line, you can see that we come up from negative infinity up to the number 2, and we stop with the closed circle. So our inequality would be x is less than or equal to 2. Now, as an alternative, you could also write it as negative infinity is less than x less than 2. Less than or equal to 2, okay? You do have alternatives, you do have options here. If it helps to write it this way to help you with interval notation, you can certainly write it that way, okay? There is no right or wrong. It could be either one of these. For set notation, we simply take the inequality and define the domain for x such that x is less than or equal to 2. Or if you use this inequality, you would simply substitute that into set notation. And interval notation, we go from negative infinity up to and including 2. Okay, so parentheses on negative infinity, bracket on 2. For the second number line, you had x is greater than 2. It is an open circle, right? An alternative, you could do 2 is less than x less than infinity. That's always an option. Interval notation, set notation, define the domain such that x is greater than 2. And interval notation, we go from 2 to positive infinity, parentheses on both because they are not included.